Howdy everybody, this video will cover the factoring basics worksheets and we're going to go over about half of the problems, so pay attention and write fast. So we're going to go over 1, 3, 5, 7, 9, and a few more. So for number 1, well, for this first section it's asking you to list the factors of each number or variable, then determine the greatest factor. So first let's break up our two numbers here, so 4 and 6. 4 breaks up to 2 times 2. And then 6 breaks up to 2 times 3. Now, what's in common between those two numbers? The 2 is the only thing in common, so your GCF will equal 2. All right, number 3, 10 breaks up to 2 times 5. 25 breaks up to 5 times 5. The only thing in common will be 5, so your GCF will equal 5. Number 5, 28. Big number, but it's pretty easy still. 28 breaks up to, let's see, 2 and 14. 14 breaks up to 2 and 7. So 2 times 2 times 7 is 28. Then 35 is just 5 times 7. So the only thing in common is 7. So your GCF equals 7. Number 7, we have 25, 30, and 15. 25 breaks up to 5 times 5. 30 breaks up to 5 times 6, and 6 is going to be 3 times 2. And then 15 breaks up to 5 and 3. The only thing in common is going to be 5. So your GCF is, your greatest common factor is 5. Number 9, we have x to the 5th and x squared. So x to the 5th breaks up to 1, 2, 3, 4, 5 x's. X squared breaks up to 2 x's. What's in common? 2 x's are in common. So your GCF will just be x times x, or x squared. Let's see, 11 and 13. Okay, not 18, just 11. Okay, so for number 11, we have 4x squared. 4 breaks up to 2 times 2. X squared breaks up to x times x. Now 16x breaks up to 2 and 8. 8 breaks up to 2 and 4, and 4 breaks up to 2 times 2. And there's 1x. Now what's in common? We have 2 2's and an x in common. So 2 times 2 is 4, 4 times x is 4x. So your GCF equals 4x. Okay, any questions? Probably not. Okay, so next section we have factoring binomials. And we're going to go ahead and go over 14, 16, 18, 20, 22, and 24. Okay, so with factoring binomials, it's the same thing we just did before, but this time there's another step, okay? So we're going to factor the GCF out of each expression. So 3x minus 6. 3x breaks up to 3 times x, minus 6 breaks up to 2 times 3. The only thing in common is your 3. So on your new expression, on the outside is going to be a 3. On the inside of your parentheses is going to be what's left, x minus 2. And that's it. Number 16, we have 2x plus 10. 2x breaks up to 2 times x, plus 10 breaks up to 5 times 2. Only thing in common is your 2. So on the outside, you're going to have a 2, parentheses, x plus 5. Number 18, we have x squared plus 3x. X squared breaks up to x times x. 3x breaks up to 3x. The only thing in common is 1x. So on the outside, you're going to have an x. On the inside of your parentheses, you're going to have x plus 3. Number 20, a little bit more difficult. 9 breaks up to 3 times 3. And we have x to the 10. So that'll be 10 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then plus 7x. Plus 7, because 7 is a prime number, doesn't break up. And then x to the 4 is going to be 4x's. The only thing in common between these two is going to be 4x's. So on the outside, you're just going to have 4x's or x to the 4. And what's left, you got 3 times 3, which is 9. And then 1, 2, 3, 4, 5, 6 x's, x to the 6, plus 7. Okay. Now, number 22. 22, we have 10x squared minus 25x. 10 breaks up to 5 times 2. X squared breaks up to x times x. Minus 25x, which is going to be 5 times 5 times x. Only thing in common is going to be a 5 and an x. So 5x is what you're going to pull out. So 5x on the outside. On the inside is 2 times 2x minus 5. (24) is tricky as well. We have negative 8x to the 10th power minus 2x to the 9th power. Negative 8 breaks up to negative 2 times 4, and 4 breaks up to 2 times 2. And then x to the 10 is going to be 10x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then minus 2, prime number, stays the same. And then 9x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's in common? We have a negative 2 in common, and then 9x is in common. So on the outside, you're going to have negative 2, and then 9x's is going to be x to the 9th power. What's left on the inside is 2 times 2 times x, which is 4x. And then a lot of y'all will say that's it. But it really isn't, because we need a placeholder for that negative x to the 9th that we just pulled out. Because when we really pull something out, we're really dividing it out. And if it divides something completely out, that means you're dividing something by itself. So when you divide something by itself, it equals 1, because like 2 divided by 2 is 1. So we need to have 4x plus 1 at the very end, so you can have a placeholder for the 2x to the 9th that you just pulled out. So then that'll be your solution right there. Okay, flip it over. We're going to go ahead and do a few more. We're going to do 26, 28, 30, 32, and 34. Okay, so for 26, well, for this whole section, it's going to be factor the groups out of each expression. So really simple. Factor the group out of each expression. So those two right there, you're going to factor out because they're the same. So on the left side, you're going to have x plus 1. Now what's left goes on the right side. So 3x plus 5 goes on the right side. And that's it. Pretty simple, I think. So for number 28, we have 3x minus 1. Well, 3x plus 1 the same. So pull those two out. So on the left side, you're going to have 3x plus 1. What's left is 2x plus 5 on the right side. Number 30. What's the same is going to be x plus 1. So on the left side, have x plus 1. And what's left over is x plus 5. 32. What's the same? X plus 1. So on the left side is going to be x plus 1. On the right side, you have 8x plus 11 left. So that'll go on the right side. Last one of this section, what's the same is, actually not 34. Let's do 31. What's the same is 7x minus 2. So that'll go on the left side. 7x minus 2. Now what's left is x plus, we have a blank. Whenever you have a blank, remember, there's the number that's in front of a of anything is 1. There's always a 1 there. So you're going to have x plus 1 for the right side. Okay, now onto the last section. Shoot, where are we at? So let's do 35, 37, 39, and one more, 41. Okay, so what are the roots of the following equations? So remember, to find the roots or the solutions or the zeros or the x-intercepts, you're going to set your binomials equal to 0 and solve for x. So we have two binomials, so x plus 5 equals 0. To solve for x, just minus 5 from both sides, and x will equal negative 5. Now set the other one equal to 0, x minus 7 equals 0. To get x by itself, add 7 to both sides, and you'll get x equals 7. So those are the two solutions to that equation. 37, x minus 4 and x minus 3. Set them both equal to 0. X equals 4. X minus 3 equals 0, x equals 3. Because you have to add 4 to both sides to get x equals 4. Add 3 to both sides to get x equals 3. 39. As you notice, we have a 7 on the outside, which we're going to ignore because it's on the outside. So just focus on the inside. X minus 3 equals 0. Add 3 to both sides. I'll get x equals 3. X plus 99 equals 0. Minus 99 from both sides. And you'll get x equals negative 99. And those are your two solutions. Now, one more to go. 41. Still, we have a lot more numbers inside, but we're still going to set them equal to 0. So 9x minus 18 equals 0. Add 18 to both sides first. You'll get 9x equals 18. To get x by itself, divide by 9. And you'll get x equals 2. Last one, 2x plus 6 equals 0. Subtract 6 from both sides. You'll get 2x equals negative 6. Divide by 2, and you'll get x equals negative 3. And that's all I'm going to do for y'all. So go ahead and do the rest of this worksheet. Remember, it's due the following Monday. Thanks for watching. Bye.